Hi. Today we're going to be going over piecewise functions, a pretty interesting element of graphing and algebra that take our understanding of both lines and functions, and even graphing, to another level. So right here we have an example of a piecewise function. And you might be wondering, why do we call them piecewise functions? Well, because just by looking at them, we can see that we have several different pieces to look at, right? We have one piece here that has a positive slope along this interval, and we have another we can see has a slope of 0 along this interval. We can see another one that has a slope of a negative slope on this interval, and one that has a 0 slope in this interval. And they all have different positions. And the first thing you might be noticing is, what are these circles? Some of them have big round circles, and the others have solid dots. And each one seems to have, each segment seems to have a open circle and a solid dot. Why is that? Well, that's because this is a function. And at first you might say, okay, that's unhelpful. What does that mean? But we call that every function, for it to be a function, has to have, for every input, one output, right? And so on a graph, that means for every x value, there can only be one y value. Otherwise, it's not a function. So if this was a point, right? If this was a solid point, then for one x value, we have two y values, right? This was 1, right? At 1, we'd have a y value of 4 and 5. We can't have that. So one of them has to not exist. And this open circle basically means that at 1, it's not there. But for every other value after 1, like 1.000001, is on this line segment. And the same thing follows here. If this was, say, 3, right? At 3, the graph is at 5. But at 3.000001, it's along this segment. And let's say we wanted to write an equation for this function, right? F of x equals what? You might say, okay, this is going to get really complex, but it's actually not that complex. Basically, you have to think about what segments do we have, and what's the range that they operate under. Because certain rules, certain equations will only apply for certain segments in this range. For example, we notice that this segment here has a slope of 0, and if we were to continue drawing this, it'd have a y-intercept of 5. So we can say at this point, we have y equals 5, right? That describes this line. But we can't just say, f of x equals 5, right? Because on other portions of this line, we have something completely different. What we say is, this bracket indicates that it's a piecewise function, that it has multiple parts. We can say it equals 5 when x is less than 1, but it's when x is greater than 1, but it's less than or equal to 3, right? Because remember, we're at a closed circle at 3, so this line does contain a 3 at x, right? It does indeed match up, where this segment doesn't, right? Let's say we want to graph, this segment, and let's say we figure out that it has a slope of 1 and a y-intercept of 2, right? So something like x plus 2. We'd say x plus 2 for its range. And here, let's say that's -3, and here, let's say that's 1. So this function is equal to x plus 2, or the broader line x plus 2, when x is greater than 3, but less than or equal to 1. We know that it's not greater than or equal to -3 because this is an open circle, not a closed circle. We know that this is less than or equal to 1 because this is a closed circle at 1. What about this segment here, right? So it's at -3. It's It's a closed circle, and then it goes on for infinity. So we can say, what if this is y equals 3? So we can say 3. But how are we going to represent this? We know it goes on for infinity. So we can say infinity. And since infinity obviously is a number that we can't reach infinity, we're just going to say less than x, which is greater than or equal to negative 3. So from negative infinity to negative 3, our function is just going to be at 3. And finally, this last part here, how are we going to break it down? Well, let's say we figured this out, we've graphed it all out. We say this is y equals negative 2x, I don't know, plus 2, right? So it's going to be 2x plus 2, because y is the same thing as saying f of x. They're both outputs for a given input x. And then what's the interval? Well, we can see not at 3, right? So it's going to be a greater than symbol because it doesn't include 3. But it does include its ending point, which I'll just say is 5, right? So 3, yeah. So from 3 to 5. And not including 3, but including 5. And of course we know that because 3 has an open circle and 5 has a closed circle. And that's the basics of piecewise functions, both how we represent them, how we find them, what they look like on graphs, and how to determine equations of piecewise functions from graphs. That's it. I hope you found it helpful, and I hope you have a great day.